Hi guys, welcome back to this special series on building 7 use cases of machine learning in Android. So today we are going to complete our audio classification use case. We have already built the audio helper activity. And in this video, we will start by integrating the TensorFlow Lite library. So this particular classification doesn't come from ML Kit, but it comes from the TensorFlow Lite model. So if you go to the TensorFlow Lite examples page, you can see they already have our own example for both iOS and Android. You can actually follow that or this one. And what they're using is a yamnet based classification model, which is available in their TensorFlow hub. So I'm going to use the same one. This is the model that I have downloaded. So the link will be in the description of the video. So let's just close and come back to our project. So just a reminder, if you're interested in learning Android using Kotlin, the new recommended programming language for Android development, I have a detailed course on my own YouTube channel. Please do check it out. All the links are in the description. So let's continue. Let's create one more package here and let's call it audio. Then just create a Java class and not an activity. So this would be our audio classification activity, which will extend our audio helper activity. And then we need to override on create and start recording as well as stop recording. So the audio classification example is a little complex compared to image because we don't just pick and analyze it and stop. We actually keep doing it at every 500 milliseconds. So we run a timer. It's like kind of a clock which keeps pinging us at every half a second. And then we'll execute the classification code at every half second. Okay, so let's start. So first, as always, we need to import the library. So let's go to build.gradle module. This is the build.gradle which says module ml series demo.app. So here, if you remember, we have already integrated all the other libraries from ML Kit, but this one is from TensorFlow Lite. So implementation. So I'll just copy paste it just to be sure. This is org TensorFlow, TensorFlow Lite task audio, and the number is 020. So let's sync and let the library get integrated with our project. So meanwhile, let's go back to our audio classification activity. So other thing that we need to do is to import the model in our assets folder. So if you remember, we have put the flowers custom model in the assets folder. So I'll just open that folder. Okay. And I'll just paste the new yamnet classification model. So I'll just copy the path or the name. So private string model equal to. So this is our model which is in the assets folder. So first we will start by adding the code to record the audio. So for that we need Android class actually, which is the audio record. This comes from android.media. So Android record. And then we will need a timer to run the task at every half second or 500 milliseconds. Next two classes that we need are coming from TensorFlow Lite. So this is the audio classifier and the tensor audio. So this is actually a wrapper around audio record. So let's just name it tensor audio. Okay, so first let us initialize the model in onCreate. So let me copy paste it to make it easier, and let's change the names. So we are doing is that we are initializing the audio classifier from the TensorFlow Lite library. So audio classifier dot create from file, and this is the path that should be in the assets folder. So you can see it takes the path from the assets folder. Okay, they've not added the documentation, but yeah. Next thing is we will create the tensor audio. Okay, so this would be our tensor audio, which would use the audio classifier to create the input tensor audio. Okay, so we have these two things to help us start recording. So whenever start recording is called, we will first show the specs of what the specification of what we are recording. So for that, we will use the specs text view. So we'll get the required TensorFlow audio format from the audio classifier, and then we'll just add number of channels and sample rate and show it as part of the specs text view. After that, we'll create the Android audio record from the classifier itself, and we will start recording. Likewise, we will also, whenever stop recording is called, we will call audio record dot stop recording. Now the next thing that we need to do is, once we start recording, is to start the timer. So first we will create the timer task and then we will start it. So timer task is equal to new timer task, and it will have a run method. So this is where we will write all the code which will execute it every half a second. So let me copy paste the code just to make it easier. So if you are getting confused or if you can't follow the code, the full code is available in the ML series demonstrator app, which is also in the description. I will just explain what we have done. Okay, so what we are doing is we are creating a list of classifications. Now these classifications are actually returned by the audio classifier. So what it is going to do is, at every half a second, we are going to ask the audio classifier to classify the audio which is getting recorded in the mic or in the attached microphone. And then once we get a list of classification, we are going to go through each of them and try to find the categories for them. And we are only going to select the categories for which the probability threshold is greater than 30%. So that is why this 0.3f here. And once we have the final output, so this is like our list of final categories that we have identified along with their score or the probability score, we will then output it in the output text view. So yeah, so we'll just have a string builder. This is used to append and concatenate strings, and then for every category we will just add category label and category score and then a new line, so that every category is printed in a new line. So our timer task is ready, and then finally we actually need to display it. So because this is running inside a timer, we need to use run on UI method, which will actually execute this final code on the UI thread and not in the timer thread. So here we are just going to set the output text on the output text view. So output string dot toString. So in case there is no classification, the string will be empty. You can have an else case and you can just print could not classify. And then finally, now we have created the class, we will initialize a new timer. So new timer dot schedule at fixed rate. Our timer task delay is 1 second, and then the period is in milliseconds, so every 500 milliseconds, which is half a second. And then when stop recording is called, we will actually cancel the timer task. Okay, so this is done. Now we need to go back to our manifest and change the entry from audio helper to audio classification, and also in the main activity. So we have this audio helper activity. Instead of that, we actually want the audio classification activity. So we actually don't want it to be exported. You can remove that. And now if I go back to main activity, I can just change it to audio classification activity. If you remember, we already have named the button as go to audio classification, so all that should work. It's giving some error that we need to have at least minimum SDK as 23. I think this is coming from the TensorFlow Lite library. So just go back to our build.gradle for the app, and here just find minimum SDK, min SDK, and change it to 23. Just do a sync and we can run it again. So if you're using TensorFlow Lite library, you can only target from API level 23 and above. So let's go to audio classification, press start recording. So we can see again, we need to connect this one. And now if I press, so this is happening because I'm streaming and the audio is going directly to my OBS studio. But you should be able to run it seamlessly. So that's it for this video. In the next video, we will integrate a custom classification built on top of this, which can identify bird sounds between 5 birds. See you there.